want you to do something for a second. Just look around the room you're sitting in right now.
Yeah, just take a look at the empty space.
Exactly. Look at the empty space, the gap between you and the wall, or, the air just hovering above your desk.
Right.
We have this deep instinctual comfort with empty space. We think of it as a baseline.
Like the absolute zero of reality.
Yeah, exactly. The logic goes that if nothing is happening there, nothing can go wrong. It is stable. It's the canvas that the rest of the universe is painted on.
But what if it's completely wrong?
Right. What if every single cubic inch of that empty space is a lie? Because it is not empty. It is a resting quantum field.
And more terrifyingly, it is not stable.
No, it's not. Right now, our entire universe, like everything you can see, touch, and measure, is likely resting on a microscopic, incredibly fragile glass floor.
Yeah, in physics, this is called the false vacuum.
And I have to be honest, once you start pulling at the threads of what that actually means...
You never look at empty space the same way again. It completely strips away any illusion of safety we have about the fundamental laws of nature.
It really does. So to understand the sheer terror of this false vacuum, we have to talk about energy landscapes, right?
Yeah, exactly. Because in quantum field theory, the word vacuum doesn't mean like a void where nothing exists.
Right.
It simply means the lowest possible energy state of a given field. So imagine a sprawling landscape of rolling hills and valleys.
I'm picturing it.
The universe, like water flowing downhill, always wants to roll down into the deepest valley possible. It wants to reach the state of absolute minimum energy.
Which is the true vacuum.
Right, that absolute rock bottom floor is the true vacuum. But mathematics describing our universe, specifically the measurements we have of the Higgs field, the mechanism that gives all matter its mass, they strongly suggest that we are not at the bottom. We're trapped in a local valley.
Like a sort of dimple high up on the side of a sheer cliff face.
Yes, exactly. So we are resting in a temporary depression on the side of this massive cliff.
And the universe just settled into this little groove billions of years ago as it cooled, right? And because we've been sitting here so long, we just assume this is the ground floor.
We assume it's the ground floor because, locally, it looks perfectly stable. I mean, if you kick a ball around inside that little dimple, it stays in the dimple.
The walls of our little valley kind of just hold us in.
Right. In the classical Newtonian world, you would be perfectly safe. As long as you don't have enough physical energy to roll the ball up and over the lip of that dimple, you just stay put indefinitely.
But we don't live in a classical world.
No, we don't. We live in a quantum universe.
And in a quantum universe, you don't need to roll over the hill.
Exactly. Because of this freak, entirely unpredictable event of macroscopic quantum tunneling, the universe can simply phase through the solid rock of that barrier.
It just punches straight through the glass floor and drops into the true vacuum below.
Yeah, and this isn't just like a theoretical curiosity. If this happens, it is the mechanism of absolute doom.
Right, because it doesn't just happen everywhere all at once. It starts small.
It does.
So let's paint the picture of what this actually looks like physically, because we are talking about a light speed apocalypse here.
It's horrifying.
It really is. So let's say somewhere in the cosmos, maybe billions of light years away, or, maybe right next to you, a tiny droplet, like a microscopic bubble of this true vacuum nucleus.
It just pops into existence.
Yeah.
And it's important to visualize that nucleation. It is a highly localized sphere where the universe has suddenly dropped down to that lower energy state.
Okay.
Now, if the bubble is too small, the tension of the bubble's skin, which we call the domain wall, the thing separating the new physics from the old physics.
It crushes it back out of existence, right?
Exactly. But if the quantum fluctuation is just large enough, and the bubble reaches a critical size, the outward pressure of that new lower energy state overpowers the surface tension.
It reaches a threshold and then it doesn't just sit there.
No, it expands spherically in all directions at a velocity asymptotically approaching the speed of light.
And you wouldn't even see it coming.
You literally couldn't.
Like the light warning you of its approach, the very photons that would carry the image of this apocalypse to your eyes are traveling at the exact same speed as the wall of the bubble itself.
Right, so you would just be sitting there, and in the span of a Planck time, the shortest meaningful measurement of time in physics, you would simply cease to exist.
It's insane, but it's not just that you die.
Yeah.
It's so much worse than just a simple explosion.
Oh, it's fundamentally different.
Because inside that expanding bubble, the true vacuum has a completely different energy state, which means the fundamental laws of physics are entirely rewritten.
That is the core horror of it. I mean, the masses of particles change, the strength of gravity, electromagnetism, the strong and weak nuclear forces, they all recalibrate.
So everything just breaks.
Everything. The very atomic bonds that hold, the carbon in your body together, the fusion reactions keeping the stars burning, they become mathematically impossible.
Wow.
The bubble just obliterates the metastable background of our reality instantly. It wipes the slate completely clean.
Erasing the universe as we know it, leaving behind this completely alien cosmos where the chemistry required for complex life almost certainly cannot exist.
It deletes the very rules that allowed us to exist in the first place.
Okay, but I want to back up a second because I am still really hung up on the tunneling aspect of it.
Sure, yeah.
How does the entire universe just, skip the barrier? If I drop a glass on the floor, I can trace the physics of it falling. I can watch it move through space.
Right.
But macroscopic quantum tunneling doesn't work like that. It's governed by this concept called the bounce action, or an instanton, right?
Yeah, the instant.
Yeah.
It's this fascinating piece of mathematics developed back in the late 1970s. It describes a non-perturbative tunneling event.
Non-perturbative, meaning what exactly?
In simple terms, it means you cannot break the transition down into small continuous steps. The math essentially says, you were here in the false vacuum. Now you are there in the true vacuum. And the barrier between was entirely bypassed.
The universe doesn't travel through the rock of the cliff face.
No. It simply ceases to exist in the dimple and simultaneously appears in thin air outside the cliff, plummeting toward the absolute bottom.
It literally skips the journey.
Exactly. It's an instant teleportation of reality's baseline.
And for decades, this was just like an abstract nightmare. It was a dark implication of quantum field theory that physicists could only write equations about on chalkboards.
Because you obviously can't observe a false vacuum decay in an astrophysical survey through a telescope.
Right, because if you saw it, it would have already hit you.
Exactly. And we cannot generate the immense, godlike energy scales required to trigger it in high-energy particle colliders.
Even places like CERN.
Right. It seemed like something we would never, ever be able to actually test.
Which is why the current state of modern physics is so staggering. Because physicists are no longer just doing math on chalkboards.
What are they doing on tables?
Yes. The relentless advancement of quantum many-body control has allowed them to simulate this exact cosmic death scenario right now on tabletop optical tables in laboratories.
It's really wild to think about.
They are building microscopic universes, holding them in a false vacuum and watching them die.
Yeah.
I really want to pull apart the architecture of this tabletop apocalypse because the way they are building these doomsday machines is just as bizarre as the theory itself.
Oh, absolutely.
They're using what are called Rydberg atom arrays.
Yeah.
And it sounds like pure science fiction.
It really does.
They start with neutral atoms, specifically rubidium-87, and they don't just have a cloud of gas floating around. They are trapping these atoms individually, one by one.
They trap them using optical tweezers.
Which, if you've never encountered optical tweezers, the mechanism is beautiful.
It's incredible engineering. They use incredibly tightly focused laser beams, specifically tuned to an 830 nanometer wavelength.
Okay, 830 nanometer.
Yeah, and light has momentum, right?
Hmm.
And it has an electromagnetic field. When you focus a laser that tightly, the electric field gradient of the beam actually exerts a physical force on the neutral rubidium atom.
Wait, it physically grabs the atom?
Basically, yeah. It polarizes the atom, creating a dipole, and that dipole is drawn to the most intense part of the laser beam. It literally pins the atom in place in the center of a vacuum chamber.
Wow.
And then they arrange these individually trapped atoms into a flawless one-dimensional periodic ring.
A perfect circle of isolated atoms suspended in absolute nothingness.
Exactly. A microscopic ring of matter floating in a vacuum.
But normal rubidium atoms sitting in a ring aren't a universe. I mean, they don't have the tension or the instability required to mimic the cosmos.
No, they're too stable.
Right. To simulate the void, they have to force these atoms into what's known as a Rydberg state. And this is where it feels like they are pushing the fabric of matter to its absolute breaking point.
Yeah, because a normal rubidium atom is tiny, the nucleus is in the center, and its single valence electron-like, the outermost electron, is tightly bound right around it. It's quiet and compact.
Okay.
But to get it into the Rydberg state, they have to inject an enormous amount of energy into that specific electron without knocking it completely free of the atom.
Because if they hit it with one massive blast of energy, the atom would just ionize, right?
Exactly. The electron would fly off and the simulation would be ruined.
So how do they pump it up without breaking it?
They use a highly specific 2-photon laser transition.
2 photons.
Right. They hit the atom with a 420 nanometer blue laser and a 1013 nanometer infrared laser simultaneously.
Okay, so blue and infrared.
The atom absorbs the first photon, which acts as a stepping stone, lifting the electron halfway up the energy ladder. And then, literally a fraction of a nanosecond later, the second photon hits, boosting it the rest of the way into the 70s principal quantum state.
Let's really visualize what this 70s state means, because when we say the electron is pushed out, we aren't talking about a slight expansion.
No, not both.
The orbital stretches up to 100,000 times its normal size.
It's massive.
100,000 times. If the nucleus of the atom was a golf ball sitting on the 50-yard line of a football stadium, the electron isn't just in the bleachers, it's orbiting the entire city.
It's absurd.
The atom physically balloons into this grotesque, bloated quantum object. It becomes a giant, fragile monster on the atomic scale. How does it even stay together?
Barely, to be honest. The Coulomb force, the electrostatic attraction holding the negative electron to the positive nucleus, is incredibly weak at that massive distance.
I bet.
But that extreme fragile size is the critical ingredient for the simulation. Because the electron is so far out, the atom becomes highly polarizable.
The electron cloud is just sloshing around.
Exactly, sloshing around and incredibly sensitive to anything nearby. So when two adjacent atoms in the ring are both pumped into this bloated Rydberg state, their giant electron clouds start to see each other.
Oh, wow.
They exert massive long-range van der Waals interactions on each other.
They start pressing against each other across the empty space of the vacuum chamber.
Exactly. And this interaction scales proportionally to 1 over r to the 6th power, where r is the distance between the atoms.
Okay, so that 1 over r to the 6th scaling, that's violent.
Very violent. As they get closer, or as they swell in size, the repulsive force between them scales up exponentially. This immense scaling tension between the bloated atoms is exactly what the physicists need to build the model.
Because that tension is the physical stand-in for the domain wall surface tension we talked about earlier.
You got it.
When a true vacuum bubble pops into existence in the real universe, the boundary between the true vacuum inside and the false vacuum outside is a domain wall.
Yeah.
And it takes immense energy to bend space and maintain that wall, which is why small bubbles are crushed by their own surface tension.
Exactly.
So the van der Waals repulsion between these giant Rydberg atoms flawlessly mimics that exact energetic penalty.
It does.
The repulsion between the atoms is literally the skin of the apocalypse holding itself together.
It is a profound mathematical mapping. I mean, you have this discrete, countable grid of physical atoms. But by tuning these extreme van der Waals interactions, the grid begins to obey the continuous equations of a cosmological field.
It's just mind-blowing. Okay, so I want to make sure I'm seeing the board clearly here.
Sure.
We have the physical grid, a ring of optical tweezers holding atoms. We have normal compact atoms, and we have the capacity to turn them into monstrous ballooned-up Rydberg atoms.
Right.
But how do we actually map the concept of the universe dying onto this? Because the math they use is called the transverse longitudinal field Ising model.
Yeah.
And that sounds like a massive wall of academic jargon.
It really does sound like jargon, but we can break it down into something very intuitive.
Please do.
The Ising model was originally designed to understand magnetism, right? But here, it's basically a way to describe a grid where every point can only be in one of two states.
Like a binary system.
Exactly.
Yeah.
Think of a row of coins that can only be heads or tails. In physics, we call it spin down or spin up.
Okay.
So in the context of our tabletop apocalypse, the spin down state is just the normal, unexcited ground state of the rubidium atom. It's small, it's quiet, it's interacting weakly.
And that represents the false vacuum, the metastable state our universe is currently sitting in.
Precisely. And the spin-up state is the bloated, massive 7ds Rydberg state.
Okay.
When an atom flips into this state, it represents a localized piece of the true vacuum. It is a piece of the universe that has died and transitioned to the lower absolute energy state.
So a false vacuum decay physically corresponds to a domain of these atoms spontaneously flipping from normal to bloated, and that domain expanding across the ring.
Exactly. That spreading is the apocalypse.
But, I mean, the atoms aren't just going to flip on their own, right?
Yeah.
The researchers have to engineer the forces driving the transition. They need to build the tuning knobs of reality.
Right.
You mentioned the transverse and longitudinal fields in that model. What do those actually correspond to in the physical lab?
This is where the engineering gets brilliant. Let's look at the transverse field first.
Okay.
In the mathematical model of the universe, the transverse field represents the intrinsic quantum fluctuations, the inherent jitter of reality that allows the tunneling to happen.
The thing that lets the ball skip through the cliff.
Exactly. It's the kinetic energy term in the system's Hamiltonian, the engine that allows the state to change. Now, in the lab, this transverse field isn't a magnet. It is the global lasers themselves.
Wait, really?
Yeah, the 420 nanometer and 10 to 13 nanometer lasers continuously bathing the entire ring of atoms.
Wait, so by shining the lasers on the atoms, they are injecting the quantum jitter?
Yes. By keeping the lasers on, they create an effective Rabi frequency. The atoms are constantly feeling this electromagnetic pressure, this driving force, urging them to flip between the ground state and the Rydberg state. It provides the energetic agitation necessary to allow the metaphorical ball to instantly teleport through the cliff face.
I see. That makes sense. But if you just bathe the whole ring in lasers, the system is totally symmetric, isn't it?
It is.
Like an atom is just as happy being normal as it is being bloated. To simulate the end of the world, one state has to definitively be lower in energy than the other.
Exactly. The true vacuum has to be the absolute bottom of the cliff.
You have to break the symmetry.
Yes, and this is where the longitudinal field comes in.
Okay, so how do they do that?
To break the symmetry, they use site-selective targeting lasers.
So more lasers.
Always more lasers. On top of the global lasers illuminating everything, they shine highly focused, separate lasers onto alternating individual atoms. Let's say they target just the even-numbered atoms in the ring.
Okay. Do these targeting lasers flip the atoms too?
No, they do something much more subtle. They apply what is called an AC Stark shift.
Okay, you're going to have to unpack the AC Stark shift for me.
No problem. Imagine you have a trampoline and you roll a billiard ball across it. It moves in a straight line, right?
Right.
Now imagine you put a heavy bowling ball in the middle of the trampoline, creating a deep dip. If you roll the billiard ball now, its path distorts.
Because the local environment has changed.
Exactly. The targeting laser is the bowling ball. By shining this specific frequency of light onto an atom, the electric field of the light distorts the electron orbitals. It physically shifts the energy levels of that specific atom up or down.
Ah. Okay, so by applying this alternating energy bias, shifting the energy of the even atoms, but not the odd atoms, they dictate the rules of the universe.
Yes.
They make it so that a specific configuration, say having a bloated Rydberg atom on all the odd sites, is mathematically the absolute lowest energy state possible.
It's the true vacuum.
And the inverse configuration becomes the higher energy, metastable false vacuum.
Exactly. They have literally, manually programmed an energy bias into the fabric of this microscopic reality. They built the cliff and they placed the universe in the dimple.
It is an astonishing level of control. I mean, they are using lasers to hold atoms in a state of existential dread, constantly feeling the pull of the lower energy state.
It's beautifully sinister when you frame it like that.
It really is. But this brings up a paradox that really stopped me in my tracks when I was looking into the setup. If simulating the end of reality is just about creating this grid, holding the atoms in a false vacuum pattern, and turning on the global lasers to act as the quantum jitter, wouldn't the whole thing just instantly collapse into chaos? Like, if you just drop atoms into a basic alternating pattern and hit them with a laser, doesn't it all just fall apart?
It absolutely does. And that was one of the primary hurdles the experimentalists faced.
Really?
Yeah, you just take a naive, basic alternating state, what physicists call a pure product Neal state.
What does that mean?
Think of it as a literal dumb checkerboard pattern. Up, down, up, down. If you just forcefully place the atoms in that pattern and then quench the system by suddenly exposing it to the tunneling lasers, you do not get false vacuum decay.
You get a mess.
You get a fake decay.
Because there's no deeper connection there.
Precisely. Because a pure product state has no deep quantum entanglement. It's essentially classical in its correlations. Every atom is completely isolated from its neighbors quantum mechanically.
Right.
So when you hit that rigid classical pattern with the intense global lasers, you introduce massive, localized energy spikes. That's like intense thermal heat.
Ah.
And this artificial chaotic thermal fluctuation just rips the state apart. The atoms flip wildly and randomly, but not through the silent, non-perturbative quantum tunneling they are looking for. It just melts.
It just melts. I think a good way to visualize this is trying to freeze a lake perfectly clear, right?
Ooh, yeah, good analogy.
If you just drop the temperature of the air instantly to absolute zero, like a sudden quench, the water freezes unevenly. The ice cracks, it shatters, and gets clouded with thermal defects. But if you want perfect, transparent ice, you have to lower the temperature a fraction of a degree at a time, allowing the water molecules to align perfectly.
That is exactly it.
To witness pure macroscopic quantum tunneling, the void must be engineered perfectly. The atoms can't just be placed in a pattern. They have to share a deep, underlying quantum consensus about their reality.
They have to be fully entangled.
Yes. And this brings us to one of the most awe-inspiring achievements of this research, the pre-quenched ground state, the PQG state.
The PQG state is the masterpiece of this simulation.
It really is.
To avoid the thermal melting, the scientists realize they can't just drop the system into the false vacuum. They have to grow it into the false vacuum organically.
Grow it.
Yeah. They use a principle called the adiabatic theorem.
Okay, walk us through the adiabatic ramp-up. How do you grow a universe?
Well, they initialize all the atoms in their normal ground states. Then, very, very slowly, they bring the global lasers, the transverse field, up to full power.
Very slow.
Yes. But crucially, while they're doing this, they keep the symmetry bias, those site-selective AC stark shift lasers, turned completely off. They hold the longitudinal field at 0.
So under these conditions, there is no false vacuum or true vacuum yet.
Right.
There is no cliff and no dimple. There are just two equally valid flat ground states.
Exactly. And by ramping the lasers up agonizingly slowly, the atoms naturally begin to talk to each other through those van der Waals interactions.
They negotiate.
They negotiate their states, they entangle, they form this pristine, profoundly correlated many-body state. The quantum wave functions of the individual atoms literally merge into a single cohesive state.
Wow.
It is a genuine quantum field vacuum. It possesses all the complex, short-range entanglement properties intrinsic to the real universe.
It is perfectly stable and perfectly interconnected, and then the trap is sprung, the quench.
Oh yeah. In a fraction of a microsecond, they instantaneously snap the site-selective targeting lasers on. They instantly apply the AC stark shift across the lattice.
In that single microsecond, the environment of the atoms is violently recast.
Completely.
The previously stable, perfectly comfortable ground state they were resting in suddenly becomes the highly metastable false vacuum.
The cliff face literally shifts beneath them.
They are now trapped in the dimple, fully entangled, and feeling the overwhelming mathematical pull of the true vacuum below.
And because they are in this highly correlated PQG state, they don't melt.
The entanglement protects them.
Exactly. The artificial thermal defects are suppressed by the entanglement. The system is too perfectly ordered to just shatter.
Right.
So the only way out of the false vacuum now is the terrifying collective mechanism of macroscopic quantum tunneling. The atoms have to collectively agree to nucleate a bubble of the true vacuum.
And when they finally ran this experiment, when they achieved the PQG state and watched the true vacuum bubble form and expand through this pristine quantum lattice, the data they got was chilling.
It perfectly matched the exponential suppression laws predicted by Sidney Coleman in the 1970s.
Sidney Coleman.
Yeah, Coleman was the physicist who formalized the mathematics of false vacuum decay. For decades, his continuous mathematics of quantum field theory instantons, the Euclidean bounds action we talked about, were completely theoretical.
Just numbers on a page.
Exactly. But here, in a discrete tabletop grid of glowing rubidium atoms, the exact same mathematical decay rates were observed.
That's incredible.
The decay rate decreased exponentially with the inverse of the symmetry-breaking field, exactly as the equations demanded.
It proved that the continuous mathematics of the universe's theoretical death strictly govern this discrete grid of atoms.
It does.
The destruction of reality isn't just a cosmological hypothetical. It is a universal quantum mechanism that functions identically whether you were talking about the fabric of space-time or a microscopic laboratory array.
It's all the same math.
But I want to expand the scope here, because a one-dimensional ring of atoms is just a line, right?
Right, it's 1D.
And if we want to truly understand the horror of the bubble expanding, we have to talk about what happens when you add dimensions. What happens if we move beyond a simple 1D ring?
The physics fundamentally shift, and the terror becomes Intensely geometric.
Intensely geometric, how so?
Well, in a one-dimensional system, the boundary between the true vacuum and the false vacuum is just 2 points. It's just the two ends of the line segment that flipped.
Like the two edges of a string.
Right. But in a two-dimensional array, the rules of the apocalypse change.
Like taking a 15 by 15 grid of these optical tweezers, now you don't just have a line, you have a plane of existence.
Exactly. In 2 dimensions, the survival of the false vacuum relies on a concept called critical curvature.
Critical curvature.
When a true vacuum bubble nucleates in 2D, it has a circumference, right? It has a physical surface area, and that surface is the domain wall.
Okay.
The energy penalty to maintain that wall scales with the perimeter of the bubble.
So it's like blowing up a balloon. The tighter the curve of the rubber, the harder the surface tension squeezes inward.
A perfect analogy. This creates an incredible threshold dynamic.
How does that work?
If a true vacuum bubble nucleates in this 2D grid due to a quantum jitter, but it is small, the surface tension is physically overpowering.
Right, the squeeze is too tight.
Exactly. The outward pressure of the true vacuum's lower energy state, the desire of the universe to drop down the cliff, isn't enough to overcome the tight inward squeeze of the domain wall.
So it just pops.
The bubble instantly collapses back in on itself. The false vacuum self-heals.
It's constantly bubbling and boiling at the microscopic level, but the bubbles crush themselves before they can do any damage.
Right.
But if the quantum fluctuations align perfectly, if the tunneling event happens over a wide enough area all at once, pushing the bubble past a specific critical threshold,
Then the math irreversibly flips.
it flips.
Once the bubble is large enough, the curvature of the boundary becomes shallow enough that the outward pressure absolutely dominates the surface tension. Once that critical size is crossed, there is no going back. It triggers an avalanche-like, unconstrained cluster growth. The surface tension can no longer hold it back.
The true vacuum just rips outward in all directions, consuming the 2D grid relentlessly.
It is the avalanche of reality breaking.
And researchers have actually simulated this using complex algorithms called tree tensor networks and physical 2D atomic arrays to watch this cluster nucleation happen.
They have.
But I think it's important to pause here and look at the broader landscape of how we simulate doom, you know?
Yeah.
Because the Rydberg array isn't the only machine physicists have built to try and probe this. But when you look at the alternatives, you realize why this specific atomic setup is so profoundly unsettling in its precision.
Definitely.
Take superconducting flux qubits, for instance. Quantum annealers.
Oh, right. Platforms like the D-Wave systems are incredibly powerful. I mean, you can link together over 5,000 superconducting qubits on a single chip.
5,000.
Yeah, they can simulate this decay in real time on a massive macroscopic scale.
But there's a fatal flaw when it comes to observing pure cosmic death, isn't there?
Yeah, the noise.
The noise.
Superconducting qubits are solid-state devices. They are built into microchips, which means they are incredibly susceptible to environmental noise. They are open, dissipative systems.
So you can't keep them isolated.
No, you can watch a quantized bubble form in a D-Wave processor, but the system cannot maintain long-time quantum purity. The delicate, silent quantum tunneling gets entirely drowned out by the noise of the environment.
It's like trying to listen to a whisper in a hurricane. You know something happened, but you can't hear the fundamental mechanism.
That's exactly.
And then you have atomic superfluids, Bose-Einstein condensates.
Right.
These are conceptually fascinating because they simulate continuous fields. You can literally use optical imaging to see the domain walls. You can look at a monitor and watch the spatial bubble expanding through the fluid. You can visually see the apocalypse.
You can, but again, it's contaminated.
Contaminated how?
In ferromagnetic superfluids, the decay process is dominated by thermal heat fluctuations, not pure macroscopic quantum tunneling.
Ah, so it's the melting problem again?
Exactly. The ambient heat activates the decay, pushing it into a classical mean field regime. The atoms essentially boil over the cliff instead of tunneling through it.
Wow.
It's an amazing visual analog, but it's completely missing the core, non-perturbative quantum teleportation that makes false vacuum decay so fundamentally terrifying.
It's simulating the visual of the death, but not the actual soul of it.
Exactly.
The Rydberg array remains the ultimate pristine sandbox because it eliminates that thermal contamination. The isolation of those optical tweezers suspended in a vacuum chamber is almost absolute.
It is.
But there is a connection here that we have to talk about, a mathematical bridge that elevates this from just a simulation of a bubble to something far more fundamental about the nature of existence.
The Schwinger connection.
Yes, the Schwinger connection.
This is where cosmology and quantum electrodynamics collide in just a breathtaking way.
Tell me about it.
So we've been talking about the transverse longitudinal field Ising model, the exact math governing the glowing atoms flipping states on this optical table.
Right.
As it turns out, that mathematics is mathematically identical, or isomorphic, to the physics describing the Schwinger effect.
And for those unaware, the Schwinger effect is the spontaneous manifestation of matter out of absolutely nothing.
It's wild.
If you take a complete perfect vacuum, no particles, no atoms, completely empty space, and you apply a staggeringly extreme electric field across it, the vacuum itself will physically tear apart.
Yeah, the extreme energetic tension forces the void to spontaneously generate an electron and a positron.
Matter and antimatter birthed from nothingness simply because the tension on the field was too high.
And in the tabletop experiment, the spontaneous generation of a true vacuum bubble amidst the metastable false vacuum perfectly mirrors the spontaneous generation of an electron-positron pair in an extreme electric field.
That is just wow.
When the researchers look at the excitation peaks in the Rydberg array, the specific frequencies where the atoms are most likely to transition, they are directly observing the analog of the bosonic modes generated during particle pair production.
The lasers flipping the bloated atoms aren't just simulating a bubble of space changing, they are mimicking the spontaneous generation of matter from nothing.
Exactly.
They are simulating the tearing of the vacuum itself. It proves that the void is active. The void has structure, and if you push it hard enough, the void will bite back and rewrite itself.
It really emphasizes the most unsettling truth of modern physics.
Oh, yeah.
I mean, empty space is an active participant in reality, not just a passive backdrop.
Okay. So we've built the doomsday machine. We've isolated the rubidium atoms, trapped them in the optical tweezers. We've achieved the pristine, pre-quenched ground state.
Right.
We've turned on the AC Stark shifts. The false vacuum is primed, shivering under the transverse field of the global lasers.
It's all set up.
The critical threshold is breached. The true vacuum bubble nucleates, and the light speed apocalypse begins to spread across the lattice. The universe is dying.
Yeah.
But then, simulation hits a climax that nobody entirely expected. A literal plot twist in the death of reality.
It hits a wall, but not a physical wall in the laboratory. A mathematical wall dictated by the geometry of the simulation.
Because up until now, we've been talking about the continuous universe, the infinite void where a bubble just expands forever, consuming light year after light year until everything is gone.
Right.
But this tabletop simulation, and potentially our own localized geometry of the universe, is finite. It is discrete.
And in a finite, discrete system, the light speed destruction cannot run infinitely. It is governed by strict, unyielding laws of resonance and energy conservation.
Resonance and conservation. So to understand this twist, we have to go back to the energy ledger of the universe, right?
Yeah, we have to look at the accounting of the apocalypse.
The accounting of the apocalypse. I love that.
Remember, creating a true vacuum bubble involves two competing forces: the energy cost and the energy reward.
I want to make sure I grasp the reward part. Why is there a reward for destroying the universe?
Because the true vacuum is the absolute lowest energy state. Think of water held behind a dam. It has high potential energy. When the dam breaks, the water crashes down into the valley below, releasing all that kinetic energy.
Oh, I see.
When a region of space drops from the false vacuum down the cliff into the true vacuum, it liberates potential energy.
Okay, that makes sense.
In our atomic lattice, creating the edge of a bubble, flipping an atom to create the domain wall boundary between the true and false vacuum, imposes a strict energy penalty.
The cost of the wall.
Let's call that penalty 4J, representing the domain wall tension. But for every single atom inside the bubble that flips into the lower energy true vacuum state, the system gains that energy reward. It liberates potential energy.
And what do we call that?
Let's call that reward 2.8, where air is the number of atoms inside the bubble.
So it costs energy to build the wall, but you get a massive payout for the volume of space inside.
Exactly. And because this atomic array is an isolated finite quantum system, energy must be strictly conserved.
Right.
The decay process cannot just absorb or vent energy into the void. It has to balance its own books. The decay can only proceed efficiently when the energetic cost of the wall is precisely, perfectly offset by the energy gained from the space inside.
The equation must balance.
Yes, 4J must equal 2J. This means the universe doesn't just decay randomly and chaotically, it only decays into bubbles of a very specific resonant size. Resonance rules everything.
So the bubble wants to expand to this resonant size. It starts eating the false vacuum, flipping atoms, trying to balance the ledger.
Exactly.
But here is the mind-bending concept that stops the apocalypse dead in its tracks. The bubble size blockade.
This is one of the most profound discoveries in finite quantum dynamics.
It's so cool.
Let's say the resonance rules dictate that the true vacuum bubble needs to reach a size of, say, 20 atoms to perfectly balance the energy ledger. It needs 20 atoms to make the math work.
Okay, 20 atoms.
But what if your entire atomic lattice, your entire simulated universe, is only 30 atoms long?
Oh. As the bubble expands, it eats up 20 atoms. It reaches resonance. The ledger balances.
But now look at what's left. Out of the 30 atoms, there are only 10 unperturbed atoms of the false vacuum remaining in the universe.
And 10 atoms is not enough physical space to spawn a second resonant bubble.
Exactly. The first bubble has physically saturated the geometry of reality. When the bubble expands beyond half the size of the total lattice, it literally runs out of room to obey the laws of physics.
The apocalypse hits a hard spatial limit. It truncates the Hilbert space, which is the mathematical space encompassing all possible quantum states.
Yes.
The universe wants to keep dying. It wants to cascade and spawn more bubbles to continue lowering its energy, but there is literally nowhere left for the death to occur.
It's stuck.
And what happens next left the researchers completely awestruck, because the universe doesn't just sit there half dead and stuck.
No, it rebounds.
It rebounds.
It triggers what is mathematically described as a Law-Schmidt echo.
A Law-Schmidt echo.
Instead of total, irreversible destruction hybridizing into a chaotic mess of multi-bubble states, the death of the universe is paused and then violently reversed. The system gets trapped in coherent two-state oscillations.
It eternally bounces back and forth.
Yes. The entire microscopic universe evolves from the pristine false vacuum, nucleates the resonant bubble, expands, hits the geometric blockade, and because it cannot go forward, the quantum evolution unitarily swings all the way back, perfectly reconstructing the original false vacuum.
And then the lasers push it forward again.
And it happens again. And again, reality becomes trapped in an infinite loop of almost dying, hitting the geometric wall and reverting to the beginning.
It's like watching a glass shatter on the floor, and then because the room is too small for the shards to scatter, they instantly reassemble themselves in your hand.
That's a great way to picture it.
And then you drop it again, over and over forever. And the most unsettling part is that it doesn't just do this slowly.
No.
It does it with a terrifying efficiency, due to a phenomenon they uncovered using something called the Schrieffer-Wolf transform.
The Schrieffer-Wolf transform is an incredibly powerful mathematical tool used to filter out all the high-energy noise and isolate the core low-energy dynamics of a quantum system.
And what did they find when they used it?
When the physicists applied it to this bouncing universe, they found something called superradiant-like enhancement.
Superradiance. Let's break that down.
Imagine a massive stadium full of people trying to do the wave. If one person stands up randomly, nothing happens.
Right.
But if the entire stadium is coordinated, the wave travels around the arena with massive speed and amplification. Because the atomic lattice has translational symmetry, meaning the atoms are in a uniform ring, and every position looks identical to every other position, the initial false vacuum state doesn't just couple to one specific location where the bubble might form.
The quantum jitter doesn't just pick one atom to start the apocalypse.
No. It couples simultaneously and indistinguishably to all possible spatial locations of the bubble at once.
Whoa.
The system exists in a quantum superposition of the bubble, forming everywhere simultaneously.
The universe is dying everywhere at once.
And because of that, the different possible bubble states constructively interfere with each other. They amplify the process.
They boost it.
It is mathematically identical to Dicks superradiance in quantum optics, where a group of atoms spontaneously emits a flash of light much faster collectively than they ever could individually.
Wow.
But quantum interference actually speeds up this eternal bouncing. The universe is oscillating between existence and obliteration at an enhanced hyper-accelerated frequency, permanently locked in this two-state rhythm because the physical geometry of the world simply isn't big enough to allow the apocalypse to finish the job.
The blockade effect sustains macroscopic many-body coherence. It acts as a protective kinetic constraint against false vacuum decay.
It does.
The apocalypse is defeated by a lack of real estate.
Essentially, yes.
And that realization that geometric limits can permanently halt vacuum collapse has incredibly broad implications.
Huge implications.
We are zooming out now from the glowing atoms on the optical table to the absolute forefront of human technology. Because this bizarre quirk of spatial saturation, the fact that the end of the world can get stuck in a doorway, might actually be the savior of modern computing.
It is the technological savior for fault-tolerant quantum computers.
Which is incredible.
We've spent this entire time discussing the false vacuum as a cosmological terror, but in quantum information science, the false vacuum is a daily engineering hurdle.
How so?
When we try to build logical qubits, the fundamental memory units of a quantum computer, we are inherently trying to hold matter in a highly entangled, metastable state.
Right.
We are intentionally placing the quantum memory in a false vacuum because that delicate elevated state is where the incredible processing power comes from.
But the universe hates the false vacuum. The memory constantly wants to decay. It wants to tunnel down to the true vacuum, which in computing terms means a tonal loss of data, decoherence, error. The computer crashes.
Exactly. False vacuum decay is the ultimate intrinsic relaxation mechanism that limits the coherence lifetime of any quantum computer. It is the grim reaper of quantum memory.
But what this tabletop simulation proved is that decay is not inevitably terminal if the architecture of the chip is carefully constrained.
Right. By engineering the exact spatial correlations we saw in the PQG state, and by intentionally designing the qubit arrays to enforce a topological size blockade, scientists could permanently arrest that decay.
You literally build the quantum chip so that any error bubble that tries to form instantly hits a geometric wall and bounces back into the correct memory state.
You use the Loschmidt echo to freeze the quantum memory in a protected eternal loop of self-correction.
It provides a rigorous physical blueprint for engineering inherently robust quantum matter.
It really does. By understanding the profound mechanics of how the universe theoretically dies, we learn how to make our most advanced technology functionally immortal.
It all comes back to boundaries, the physical truncation of the space. Which brings me to the final provocative thought of this entire exploration. I want you to step back from the lasers, the Rydberg atoms, the quantum computers, and look up at the night sky.
Okay.
Our universe, according to the Higgs field measurements in the Standard Model, is theoretically sitting in a false vacuum right now.
It is.
It is a metastable state. It should decay. The thermal fluctuations of the extreme early universe, or just billions of years of quantum jitters, should have punched through that glass floor by now.
Statistically.
The bubble should have nucleated, the light speed apocalypse should have happened, and yet it hasn't. We have survived for 13.8 billion years without decaying.
It's a huge mystery.
We look out into the void and we assume it's because our universe is massive and stable. But what if it's not?
Right.
Ask yourself this. What if the reason we are still here isn't because the glass floor is thick, but because our universe is structurally finite? What if our reality's survival relies on unseen, macroscopic topological boundaries, a cosmic bubble-sized blockade on a scale we cannot even comprehend?
That is deeply unsettling.
What if the universe has tried to die but ran out of room, and we are currently living inside an eternal cosmic echo, trapped in a loop of almost ending, reverting back, and surviving simply because there isn't enough space for the true void to finish the job?
It leaves you to ponder the hidden architecture of the void. We might not be resting on a stable foundation. We might just be trapped in a space too small for our own destruction.
Think about that the next time you look at empty space.